All right, you guys, so let's take a look at section 3.6. Today when we go through this, there's a lot of pretty difficult problems. We're going to narrow it down to only 2 examples and narrow down the assignments a little bit to make it a little more doable. Make sure you have your book out and you're following along with me. And make sure you have your calculator out because we're going to be using it for both the examples we do today. Okay, so for example 1, a rectangle is inscribed within a parabola in quadrant 1 as shown. Okay, so this is what we're talking about. Okay, so we're putting a rectangle into quadrant 1, and they're saying that the base, one base of that rectangle is on the x-axis, one is on the y-axis, and one corner is on that parabola somewhere. Okay? So, the equation of that parabola is 18 minus 0.5x squared. We're supposed to find a function of a single variable that models the area of all such rectangles. Okay, well, let's think back. The area of a rectangle is base times height. Okay, so that base is just going to be x, right? It's on the x-axis, so if that coordinate is x, that distance is x right there. Okay, now the height I have listed as y over here, but in order to generate that 18 minus 0.5x squared, that's ultimately what that y coordinate is going to be. Okay? Because when I put in this x, whatever it is, I have to put it into that equation to get the y value. So to stick to one variable, which is what they want, that's what I'm going to use for my y coordinate. Okay? So my area is going to be my base, which we said was x. That was the bottom of that rectangle. And our height is going to be that 18 minus 0.5x squared. Okay, now the domain, 0 to 6. Well, if I put in a 0, I'm going to get 0 for an area. So I don't want to go any lower than that or I'm going to get negative numbers. And if I put a 6 in over here, I get 18 minus 18, which is also 0. So if I go any higher than 6, I get a negative area. So that is the relative domain here. Typically I can put in whatever number I want, but to make it make sense in context, I need to stop at 6. All right, so find the area of a rectangle when x equals 5. All right, well then I'm going to take my equation, I'm just going to put a 5 in, you guys. 5 squared is 25, half of 25 is 12 and a half, 18 minus 12 and a half is 5 and a half times 5 is 27.5 square units. There's your area. You could plug that into the calculator, no problem. So far, not too bad. The next problem is where you need to get your calculator involved. So if you don't have it out, make sure you grab it. Find the value of x that will give the largest possible area. Okay, so the idea is I'm going to put this into my y equals, this x times 18 minus 0.5x squared, because that represents my area, and I'm going to try to maximize it. Okay, so you're going to set up your window. Again, my domain was only 0 to 6, so I went a little bit farther to 8. When we put in a 5, we got 27 and a half, so I went to 50 to make sure that we would probably have a big enough number. And then I graphed it. Okay? And you get a portion of a cubic is what you get. But there's clearly a maximum there. And so I need to ask the calculator where that's going to occur. So if you press second trace, which is the calculate menu, and you go down to maximum, there'll be some options for you there. It'll ask you for a left bound. You'll put the cursor over here to the left of the max and press enter. Then it'll ask you for a right bound. You go over to the right of that max and press enter. And then it'll ask you for a guess. So get somewhat close to where you think the max is, press enter, and it will calculate that for you. Okay? So it says when x is 3.464, you will get an area of 41.569, which is the maximum area. So the question was, what x value will maximize the area? That's your answer right there. Okay? There'll be a few problems in the homework today that are going to ask you to maximize and minimize things. This is how you're going to do it. All right, on to example 2. So the graph of a parabola defined by 9 minus x squared is shown. Okay? So that's that graph of 9 minus x squared. And then there's a point 6,6. And we're supposed to find a function that represents the distance between them. Okay? So any point on this parabola is going to be x, y, but the y coordinate is going to be found by putting it into 9 minus x squared, just like that. And so if you think of what we did earlier, we're going to use that idea. Okay? Whoops, sorry. So we're going to take the distance formula, which if you recall, it's right up here, the square root of the change in x squared plus the change in y squared. And I'm going to plug in that x and then comma 9 minus x squared is my xy. So for this xy, again, we're going to go x and then 9 minus x squared. And if I plug that into the formula, my two x coordinates are x and 6. Okay, so x minus 6 quantity squared. My y coordinates are 9 minus x squared and 6. So 9 minus x squared minus 6 quantity squared. I'm plugging 6, 6, and x comma 9 minus x squared into the distance formula. And so now I've got a function in one variable that represents the distance between a point 6, 6 and any other point on that parabola. Okay? Use the function to find the distance between 6, 6 and 1, 8. Well, that's going to be d of 1. In other words, I'm putting a 1 back into this equation. So 1 minus 6 is negative 5 squared is 25. 9 minus 1 is 8, minus 6 is 2, squared is 4. So you get 25 plus 4, 29, and the square root of that. So the square root of 29 is that distance between 6, 6 and 1, 8. I didn't need the 8 because the 8 was generated by putting the 1 into here. Okay? Now, calculator stuff again. Make sure you have your calculator out. Use the function to find the point on the parabola that is a minimum distance from 6, 6. Okay? Well, just visually, guys, from 6, 6, a minimum distance is going to be over here somewhere. We're not going to go down here way over to this other side. So I'm going to have my x be 0 to 4 to really cover what's going on. We can talk about our y in a second, but x is going to go 0 to 4. Again, I'm graphing that same square root equation that I had on the previous page. It's in the book if you have a hard time reading that. And then when we put in a 1, we got, what, the square root of 29, which was 5 point something. So I went to 10 to make sure it was going to be plenty high. And when I graph this, I get this goofy looking curve here. But it clearly has a minimum, and that's what they're asking me to find. So if I go into calculate again, so second trace, and I choose minimum this time, I will be walked through some steps. Left bound, so I'll put the cursor over here and press enter. A right bound, I'll put the cursor over here and press enter. And then a guess. I'm going to put the cursor where, as close as I can, press enter. And it's going to give me my x. It's saying when x is 2, you're going to get this area, or this distance of 4.1, which is the minimum distance. Okay? And the question was, what should x be to make that happen? Well, x is going to be 2. Okay? And so I'm going to stop there. I think those two examples will take you through the assignment that I want you to see. So there's your assignment. 5 through 31 odds. It's different than what's on the sheet that I gave you, so make sure you pay attention to that. Good luck, you guys.